Hi, I'm Dr. De Bruin, and this is a walkthrough of how to answer an exam question from the acids and bases topic of AQA A-level Chemistry. This time we're going to add an acid to an acidic buffer and see what happens to the pH. The previous two videos are what I think of as level 1A and 1B calculations. We were just looking at what the pH is if we make a buffer from scratch, and we haven't done anything to it yet. But this is then a level 2 calculation, because now we're making a buffer and then we're modifying it by adding a small amount of base, or in this instance, a small amount of acid. So it really helps if you can get into your head that a question where you change a buffer is effectively an equilibrium question. So remember Le Chatelier's principle, and remember that if this question was about Kc or Kp, you would probably be giving your working out in the form of an ice table. And so this is just a modified ice table. So we're going to start off with initial concentration, and we're given the initial concentration of this propanoic acid. So I can just write that into my table. Now, I wouldn't be able to do that if this was a buffer that was made from mixing two solutions, which is what we did in the previous video. In that case, I would need to do concentration 1 times volume 1 is concentration 2 times volume 2 and work out the new concentration before I even started. But here I'm adding a solid to the acid, so I can just write that in. But what I do need to do is to work out what's going on with my potassium propanoate. So I know that mass is Mr. Mole, everybody's favourite equation, and so 3.37 grams is going to be 112.1, that's the relative formula mass of potassium propanoate, multiplied by the number of moles, and therefore my number of moles is about 0.0301. That's not the full calculated display, but it's okay to be rounding. So I could at this point work out that the concentration is going to be 0.0301 divided by 0.5, which gives me about 0.0601. Yes, I know that doesn't work out exactly, but it's because I'm still using my calculated display from the previous bit. So I could do that and then say, okay, well, it's half a decimeter cubed, so how many moles is that? But actually, I could just skip that step completely because I don't really need it. The reason I want the concentration is so I can work out the moles, and actually I've already got that. So I could just leave that top right box blank, it would be fine. But on the left hand side, I am going to need to work out how many moles of the acid I've got. So we're going to start off with concentration, and then we want initial moles. So this would be traditionally the first line in our ice table. Now we need to think about what's going to happen when we add some acid. So this is where it's important to bear in mind that this is an equilibrium. So every time you add hydrogen ions, that is going to favour the reaction that will get rid of hydrogen ions. And the way that we get rid of hydrogen ions is to make more acid. And in doing so, we're going to soak up anions that are already in the solution. So when you add acid, that will join together with the propanoate ions that are in that solution to turn back into propanoic acid. So I need to work out how many moles of hydrogen ions I'm adding, so I can do that. And then I can say that for every one hydrogen ion I add, that's going to use up a propanoate ion. And for every one hydrogen ion I add, that's going to produce one propanoic acid molecule. So I've got the moles at the start, I've got the change in moles, and now I can do the moles at the end. So I can do that for both of those. So that's the end of my traditional ice table, if this was an equilibrium question, and we now need to go back to concentrations. And this is the step that people very, very frequently miss. Or they don't miss it, but they forget to include all of the volumes. So remember here, we've got our propanoic acid, but we've also added 10 centimetres cubed of hydrochloric acid. So when I work this out, my total volume is going to be 0.51 decimeters cubed, because I'm adding together those two volumes there. So I'm going to have a new concentration of the acid of 0.051 and a new concentration of the ethanoate ions of 0.057. So now I'm going to put this back into my Ka expression. My personal preference is always to write out Ka in full with the actual chemicals that you're using, but I don't have a lot of space here. And actually, if it's within your working out for a question, it's entirely legitimate to do this. You're not going to lose any marks for not having written it out in full. So we can rearrange that to make the hydrogen ions the subject, and then evaluate that to find out that we've got a concentration of hydrogen ions of 1.208 times 10 to the minus 5. And then we know that pH is negative log base 10. And if we do that, we get this long string, which we're obviously going to round to 2 decimal places. Thanks very much for watching, and I hope your revision for A-level paper 1 is going well. If you are finding these videos useful, then feel free to let me know in the comments which topics you want me to focus on, and don't forget to like and subscribe, and I'll be back soon with some more A-level chemistry videos.